Explosion-proof alternators are available from suppliers such as Gringer, Automation Direct, and Rittel. NEC Article 501.125 defines explosion-proof motors as a motor in which the parts that may produce sparks or flashes are enclosed in a chamber and the chamber is filled with an approved gas or liquid that is incapable of supporting combustion and that will not burn or produce flammable vapor when mixed with air. Current ECM setups on engines like CATC 9, 15, and 18, and the Cummins QS 8.3 are not currently approved for Class 1, Division 2 locations. They would need to be enclosed, purged, or otherwise protected to meet the requirements. It is recommended to take the following actions. Firstly, contact the engine manufacturers, that is CAT and Cummins, for specific guidance on meeting Class 1, Division 2 requirements. Secondly, consult with a qualified electrical engineer to design an appropriate enclosure or purging system. Thirdly, ensure that all electrical components, including alternators, are certified for use in Class 1, Division 2 locations. Class 1, Division 2 locations are areas where flammable gases, vapors, or liquids may be present in air under abnormal conditions. These locations require specialized equipment and wiring methods to prevent ignition of the flammable materials. Explosion-proof equipment is designed to contain an internal explosion without allowing it to propagate to the surrounding atmosphere. This is achieved through robust enclosures, sealed connections, and other safety features. The National Electrical Code, or NEC, provides detailed requirements for electrical installations in hazardous locations, including Class 1, Division 2 areas. Article 501.125 specifically addresses motors and generators in these locations. The code specifies the types of equipment that are permitted, as well as the installation methods that must be followed. When selecting explosion-proof alternators, it is important to ensure that they are certified by a recognized testing laboratory, such as Underwriters Laboratories, or OL, or FM approvals. These certifications indicate that the equipment has been tested and found to meet the applicable safety standards. In addition to explosion-proof alternators, other electrical components used in Class 1, Division 2 locations must also be certified for use in these areas. This includes wiring, conduit, junction boxes, and lighting fixtures. All electrical equipment must be properly grounded to prevent the buildup of static electricity, which could create a spark. Regular inspections and maintenance are essential to ensure that explosion-proof equipment continues to function properly. Any damaged or deteriorated components should be replaced immediately. Personnel working in Class 1, Division 2 locations should be trained on the hazards of these areas and the proper use of explosion-proof equipment. They should also be aware of the emergency procedures to follow in the event of a fire or explosion. Purging systems are often used to protect electrical equipment in Class 1, Division 2 locations. These systems use a continuous flow of clean, dry air or inert gas to remove any flammable materials from the enclosure. Purging systems must be designed and installed in accordance with the NEC and other applicable standards. Enclosures are another common method of protecting electrical equipment in Class 1, Division 2 locations. These enclosures are designed to prevent flammable materials from entering the enclosure and coming into contact with the electrical components. Enclosures must be constructed of durable materials and must be properly sealed to prevent leaks. The choice between purging systems and enclosures depends on the specific application and the type of equipment being protected. In some cases, a combination of both methods may be used. When selecting a purging system or enclosure, it is important to consider the size and shape of the equipment being protected, as well as the environmental conditions in the area. The system or enclosure must be large enough to accommodate the equipment and must be able to withstand the temperature, pressure, and humidity of the environment. In addition to the NEC, other standards and regulations may apply to electrical installations in Class 1, Division 2 locations. These include standards from the Occupational Safety and Health Administration, or OSHA, and other industry-specific standards. It is important to be familiar with all of the applicable requirements before designing or installing electrical equipment in a hazardous location. Consulting with a qualified electrical engineer is highly recommended to ensure that all applicable requirements are met. An electrical engineer can help to assess the hazards of the location, select the appropriate equipment, and design a safe and compliant installation. The ECM, or Engine Control Module, setups on engines like CATC 9, 15, and 18, and the Cummins QS 8.3 are not typically certified for use in Class 1, Division 2 locations without additional protection. These ECM contain electronic components that could potentially generate sparks or heat, which could ignite flammable materials. To use these ECM in Class 1, Division 2 locations, they must be enclosed in an explosion-proof enclosure, purged with clean air or inert gas, or otherwise protected to prevent ignition. Contacting the engine manufacturers CAT and Cummins is essential to obtain specific guidance on meeting Class 1, Division 2 requirements for their engines. They can provide information on the available options for protecting the ECM and other engine components. They can also provide guidance on the installation and maintenance of these systems. In addition to the engine manufacturers, consulting with a qualified electrical engineer is also recommended. An electrical engineer can help to assess the hazards of the location, select the appropriate protection methods, and design a safe and compliant installation. The electrical engineer can also provide guidance on the NEC and other applicable standards. Ensuring that all electrical components, including alternators, are certified for use in Class 1, Division 2 locations is crucial for safety. Certification indicates that the equipment has been tested and found to meet the applicable safety standards. Certified equipment is designed to contain an internal explosion without allowing it to propagate to the surrounding atmosphere. This is achieved through robust enclosures, sealed connections, and other safety features. When selecting electrical components for Class 1, Division 2 locations, it is important to look for certifications from recognized testing laboratories, such as UL or FM approvals. These certifications provide assurance that the equipment is safe for use in hazardous locations. In summary, complying with Class 1, Division 2 requirements for electrical installations involves a combination of factors, including selecting certified equipment, providing appropriate protection for non-certified equipment, following the NEC and other applicable standards, and consulting with qualified professionals. By taking these steps, it is possible to create a safe and compliant electrical installation in a hazardous location. Remember to prioritize safety and compliance when working in Class 1, Division 2 locations. The consequences of a fire or explosion can be devastating. By following the proper procedures and using the appropriate equipment, it is possible to minimize the risk of an accident. It's also important to stay up to date on the latest standards and regulations for electrical installations in hazardous locations. The NEC is updated every 3 years, and other standards may be updated more frequently. By staying informed, you can ensure that your electrical installations are always in compliance with the latest requirements. Explosion-proof alternators are designed with specific features to prevent explosions in hazardous environments. These features include robust enclosures, sealed connections, and flame arresters. The enclosures are typically made of thick metal and are designed to withstand the pressure of an internal explosion. The sealed connections prevent flammable gases or vapors from entering the enclosure. The flame arresters are designed to quench any flames that may escape from the enclosure. When selecting an explosion-proof alternator, it is important to consider the specific requirements of the application. These requirements may include the type of flammable material present, the temperature range of the environment, and the size and power requirements of the alternator. It is also important to consider the certification requirements for the alternator. The alternator should be certified by a recognized testing laboratory, such as UL or FM approvals. Installing an explosion-proof alternator requires specialized knowledge and skills. It is important to follow the manufacturer's instructions carefully and to use the appropriate tools and equipment. The alternator should be properly grounded to prevent the buildup of static electricity. The wiring connection should be made in accordance with the NEC and other applicable standards. Regular maintenance is essential to ensure that an explosion-proof alternator continues to function properly. The alternator should be inspected regularly for any signs of damage or deterioration. The wiring connections should be checked to ensure that they are tight and secure. The enclosure should be cleaned to remove any dust or debris. If any problems are found, they should be corrected immediately. Using explosion-proof equipment is just one aspect of creating a safe electrical installation in a hazardous location. It is also important to follow safe work practices and to provide adequate training for personnel. Personnel should be trained on the hazards of the environment, the proper use of explosion-proof equipment, and the emergency procedures to follow in the event of a fire or explosion. Safe work practices include avoiding the use of open flames or other sources of ignition in the area, wearing appropriate personal protective equipment, and following lockout-tagout procedures when working on electrical equipment. By following these guidelines, it is possible to create a safe and productive work environment in a hazardous location. The information provided is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or other expert before making any decisions about electrical installations in hazardous locations. Remember that safety is always the top priority when working in hazardous locations. By taking the necessary precautions, it is possible to minimize the risk of accidents and injuries. Understanding the nuances of Class 1, Division 2 environments is critical for ensuring safety and compliance. These areas, while not continuously hazardous, present a risk of explosion due to the potential presence of flammable substances under abnormal conditions. The key is to prevent ignition sources from coming into contact with these substances. This is achieved through various methods, including explosion-proof equipment, purging, and encapsulation. The selection of the appropriate method depends on the specific application and the characteristics of the hazardous substances present. Regular inspections and maintenance are crucial for ensuring the continued effectiveness of these safety measures. Any signs of damage or deterioration should be addressed promptly. Training is also essential for personnel working in these areas. They must be aware of the hazards, the proper use of equipment, and the emergency procedures to follow. By adhering to these principles, it is possible to minimize the risks associated with Class 1, Division 2 environments and create a safe working environment. Remember to always consult with qualified professionals for guidance on specific applications and to stay up to date on the latest standards and regulations.